Hello, everyone. So let us continue our discussion on intelligent systems. No? So here's the outline of our presentation. We will discuss what machine learning is, its examples, types of machine learning, its importance, programming languages for machine learning, and its challenges. So without further delay, the definition of machine learning is it is a subset of AI that involves the development of algorithms that enable machines to learn patterns and make decisions without explicit programming. Okay, so this is the ability, no, of the machine to learn patterns without decisions, without making decisions, no, without explicit programming. So its examples are image recognition, speech recognition, recommendation systems, autonomous vehicles, and predictive analytics. So ano ba itong image recognition na to? So image recognition involves training a machine learning model to identify and classify objects or patterns within digital images. For example, no, teaching a model to recognize different species of flowers in photographs. Aside from that, recognizing cats, dogs, apples, and mangoes. So those are an example of machine learning specifically for image recognition. Next one is speech recognition. So ano naman itong speech recognition na to? So speech recognition is the technology that enables machines to what? To understand and interpret spoken languages. For example, no? Developing a system that transcribes or ini-interpret or tinatranslate no, spoken words into written text in real time. For example, tawag dito, speech to text. Yan, those are examples of speech recognition. No? The third one is recommendation system. Ito naman, no, recommendation systems used machine learning algorithms to suggest, no, to offer, to recommend items based on the user's preferences and behaviors. So dito magbibigay si system ng mga recommended items niya sa'yo. For example, ang pattern na binibigay mo is like kang tumitingin ng bags, sapatos, shoes. So si ML or si machine learning will use recommendations or machine learning algorithms to suggest these kind of items for you. Okay? So, yeah, for example, another example is a movie recommendation. Huh? Suggesting films based on your viewing history. For example, mahilig ka sa mga adventures, war, yan, di ba? Anime. So, ire-recommend sa iyo ng system kung anong pwede mong panoorin. No? It uses machine learning algorithms. Okay. Next one is autonomous vehicle. Okay. So machine learning is crucial for self-driving cars to make decisions based on real-time data from sensor and cameras. For example, you are training an autonomous vehicle to recognize and respond to traffic signs and obstacles. No? For example, meron siyang cameras na na-identify niya na 40 ang sign. No? So, ibig sabihin, ang tatakbuhin lang ng vehicle mo is 40 kilometers per hour. Kasi na-detect ng camera through image recognition yung 40, di ba? So, isa-suggest niya sa system na, oh, ikaw, dapat ang takbo mo lang is 40 kasi nakita ko ng camera ko, na-recognize ko na 40 lang dapat ito. So, that's how machine learning algorithms help these self-driving cars to make decisions based on its sensors and its cameras. Next one is predictive analysis. So, predictive analytics involves using machine learning to what? To analyze historical data, and make predictions about future trends or events. So, magbe-base si machine learning dito sa mga history or historical data mo para sa ganun mag-predict siya or gumawa siya ng projection ng possible future trends or events based again on this historical data that this machine learning is about to analyze. Okay? For example, forecasting stock prices based on historical market data. Okay? So those are the examples of machine learning, image recognition, speech recognition, recommendation systems, autonomous vehicles, and predictive analytics. So, to augment our idea about machine learning, let us watch these following videos.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out, on its own, that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk. Follow.
What is machine learning? Hello, my name is Richard Kirschner. I'm with the Simply Learn team. That's www.simplylearn.com. Get certified, get ahead. Today we're covering what is machine learning. What's in it for you? We're going to cover the basics of machine learning. What is machine learning? Artificial intelligence versus machine learning versus deep learning. How does machine learning work? Types of machine learning prerequisites, applications of machine learning. Here we have our, it looks a little bit like Frankenstein, our Frankenstein-looking robot. Today, let me tell you what is machine learning. Machine learning works on the development of computer programs that can access data and use it to automatically learn and improve from experience. Watch a robot builder construct a house in 2 days. This was back in July 29th, 2016, so that's pretty impressive. This amount of time to continue to grow in its development. And it's smart enough to leave spaces in the brickwork for wiring and plumbing, and can even cut and shape bricks to size. Amazon Echo relies on machine learning, and with more data it becomes more accurate. Play your favorite music, order pizza from Domino's, voice control your home, request rides from Uber. Have you ever wondered the difference between AI, machine learning, and deep learning? Artificial intelligence, a technique which enables machines to mimic human behavior. This is really important because this is how we are able to gauge how well our computations or what we're working on works, is the fact that we're mimicking human behavior. We're using this to replace human work and make it more efficient and make it more streamlined and more accurate. And so the center of artificial intelligence is the big picture of all this put together. IBM Deep Blue Chess, electronic game characters. Those are just a couple examples of artificial intelligence. Machine learning, a technique which uses statistical methods, enabling machines to learn from their past data. So this means if you have your input from last time and you have your answer, you use that to help prove the next guess it makes for the correct answer. IBM Watson, Google search algorithm, email spam filters, these are all part of machine learning. And then deep learning, which is a subset of machine learning, composing algorithms that allow a model to train itself and perform tasks. AlphaGo, natural speech recognition. These are a couple examples. Deep learning is associated with tools like neural networks where it's kind of a black box. As it learns, it changes all these things that are, as a human, we'd have a very hard time tracking. And it's able to come up with an answer from that. Now let's see how machine learning works. First, we start with training the data. Once we've trained the data, we go into the machine learning algorithm, which then puts the data into a processing, which then goes down to another machine learning algorithm. And then we take new data, because you have to test whatever you did and make sure it works correctly, and we put that into the same algorithm. Once we do that, we check our prediction, we check our results, and from the prediction, if we've set aside some training data and we find out it didn't do a good job predicting it, and it gets a thumbs down as you see, then we go back to the beginning and we retrain the algorithm. And a lot of times it's not just about getting the wrong answer, it's about continually trying to get a better answer. So you'll see the first time you might be like, oh, this is not the answer I want, depending on what domain you're working in, whether it's medical, economical, business, stocks, whatever. You try out your model, and if it's not giving you a good answer, you retrain it. If you think you can get a better answer, you retrain it, and you keep doing that until you get the best answer you can. Let's see the types of machine learning. Supervised learning, unsupervised learning. There's a number of ways to divide up machine learning and how it works. These are two main categories you can divide it into. Supervised learning, we have a known amount of data. So in this case, we have a bunch of apples. We have a machine learning algorithm. It goes through the process. It goes through and trains a model based on that known data. And then once you've trained your model on the known stuff, you can then put an unknown data in there and you get a new response. And of course, in this particular one, it's an apple. So it's trying to figure out whether it's an apple or another fruit. There are many different algorithms you can use for computing this information, for doing this supervised training. Just to list some of the top ones that are currently being used, and by no means there's more than just this. So by no means this isn't the complete list. There's polynomial regression, there's a random forest, there's linear regression, there's logistic regression, there's decision trees, there's k-nearest neighbors, and there's naive Bayes. Like I said, this is just a short list of some of the many tools that are out there nowadays. And if you have supervised learning, then we should also look at unsupervised learning. Unsupervised learning. So we have unknown data. In this case, you can see we have a bunch of fruit, and we might not have labeled it. We don't know. We've never had anybody look at it and say, this is what this is. And we take that data, and we put it through the machine learning algorithm. And then that goes through the processing, and then the trained model. And what the trained model says, hey, can I see a pattern here? And from that pattern, it divides it up into a response, in this case, apples and pears. You can see some of these things look just like the other, and it tries to put them all together so that you get similar things in similar groups. And again, we have a nice list of algorithms here, and this is not the only algorithms used for this. So don't limit yourself to just these. These are just some of the primary ones used today. And of course, we have the k-means clustering, singular value decomposition, fuzzy means, partial least squares, a priori, hierarchical clustering, principal component analysis. Machine learning prerequisites. Computer science, fundamentals and programming. So any of the machine learning out today, you have to know some basic scripting or programming. Intermediate statistical knowledge. You have to understand a little bit about probabilities. If A is current, how likely is B going to happen? If there's clouds overhead, how likely is it going to rain? Linear algebra and intermediate calculus. The linear algebra is very important because you have to understand basically drawing a line through the data points and what that means. That's the most fundamental linear regression models. You draw a line through all your data and you use that line to compute new values. Intermediate calculus means you need to have a little bit of understanding of what a differential equation is. You really don't need to be an expert because the computer does all the heavy lifting for you, but it's important to know the terms when they come up, unless you're doing some advanced programming on the actual models themselves. And data wrangling and cleaning. I would say this might be the biggest one in here, is you have to start getting a grip on how to clean up your data. There's a saying is, bad data in, bad data out. Good data in, you're more likely to have good data out. Some applications of machine learning. Instance segmentation. Object detection, instance segmentation. You can see here where they use machine learning to go in there and find where the different cats are and the different objects are in the picture. And then in segmentation, it actually cuts them out. Kind of a fun one, especially if you have a Google Pixel phone and you can do little animation objects on top of your ongoing pictures you're taking or movies. Number plate detection. You can see here where we have a car and it comes in there and it finds a number plate on the car. Once it's done that, it can then do automatic translation. Automatic translation is we pick up some symbols, in this case on a machine, and it does machine translation so that you can know what it's saying even if you don't speak that language. So to summary, we covered the basics of machine learning. What is machine learning? We talked a little bit about the process or the workflow of machine learning. We've looked at two different divisions of machine learning, supervised and unsupervised. We went over the prerequisites you should have going into machine learning. That you should have the basic fundamentals or a little bit of computer science and programming or scripting skills. You should know some basic linear algebra and maybe some little bit of calculus and differential equations as part of the calculus. You should have some basic intermediate statistical knowledge of what that means and what those terminology means. And you should have an idea of what data wrangling and cleaning is. How do you take your data coming in, making sure you don't have missing values, make sure that you're switching float values so they're processed correctly, integer values, versus something that's categorically like yes, true, yes, no, true, false. And then we looked at a couple applications of machine learning. Of course, there are so many applications out in today's market. It's one of the biggest growing markets out there. This is just a very brief summary of some of the things that are going on. Again, thank you for joining us today. For more information, visit www.simplylearn.com. Get certified, get ahead.
The world is filled with data, a lot of data. Pictures, music, words, spreadsheets, videos, and it doesn't look like it's going to slow down anytime soon. Machine learning brings the promise of deriving meaning from all of that data. Arthur C. Clarke famously once said, "Any sufficiently advanced technology is indistinguishable from magic." I've found machine learning not to be magic, but rather tools and technology that you can utilize to answer questions with your data. This is Cloud AI Adventures. My name is Yufeng Guo, and each episode we will be exploring the art, science, and tools of machine learning. Along the way, we'll see just how easy it is to create amazing experiences and yield valuable insights. The value of machine learning is only just beginning to show itself. There's a lot of data in the world today, generated not only by people, but also by computers, phones, and other devices. This will only continue to grow in the years to come. Traditionally, humans have analyzed data and adapted systems to the changes in data patterns. However, as the volume of data surpasses the ability for humans to make sense of it and manually write those rules, we will turn increasingly to automated systems that can learn from the data, and importantly, the changes in data, to adapt to a shifting landscape. We see machine learning all around us in the products we use today. However, it isn't always apparent that machine learning is behind it all. While things like tagging objects and people inside of photos are clearly machine learning at play, it may not be immediately apparent that recommending the next video to watch is also powered by machine learning. Of course, perhaps the biggest example of all is Google Search. Every time you use Google Search, you're using a system that has many machine learning systems at its core, from understanding the text of your query to adjusting the results based on your personal interests, such as knowing which results to show you first when searching for Java, depending on whether you're a coffee expert or a developer. Perhaps you're both. Today, machine learning's immediate applications are already quite wide-ranging, including image recognition, fraud detection, and recommendation systems, as well as text and speech systems too. These powerful capabilities can be applied to a wide range of fields, from diabetic retinopathy and skin cancer detection to retail, and of course, transportation in the form of self-parking and self-driving vehicles. It wasn't that long ago that when a company or product had machine learning in its offerings, it was considered novel. Now, every company is pivoting to use machine learning in their products in some way. It's rapidly becoming, an expected feature. Just as we expect companies to have a website that works on your mobile device or perhaps an app, the day will soon come when it will be expected that our technology will be personalized, insightful, and self-correcting. As we use machine learning to make human tasks better, faster, and easier than before, we can also look further into the future when machine learning can help us do tasks that we never could have achieved on our own. Thankfully, it's not hard to take advantage of machine learning today. The tooling has gotten quite good. All you need is data, developers, and a willingness to take the plunge. For our purposes, I've shortened the definition of machine learning down to just 5 words. Using data to answer questions. While I wouldn't use such a short answer for an essay prompt on an exam, it serves a useful purpose for us here. In particular, we can split the definition into two parts: using data and answer questions. These two pieces broadly outline the two sides of machine learning, both of them equally important. Using data is what we refer to as training, while answering questions is referred to as making predictions or inference. Now, let's drill into those two sides briefly for a little bit. Training refers to using our data to inform the creation and fine-tuning of a predictive model. This predictive model can then be used to serve up predictions on previously unseen data and answer those questions. As more data is gathered, the model can be improved over time and new predictive models deployed. As you may have noticed, the key component of this entire process is data. Everything hinges on data. Data is the key to unlocking machine learning, just as much as machine learning is the key to unlocking that hidden insight in data. This was just a high-level overview of machine learning, why it's useful, and some of its applications. Machine learning is a broad field, spanning an entire family of techniques for inferring answers from data. So in future episodes, we'll aim to give you a better sense of what approaches to use for a given data set and question you want to answer, as well as provide the tools for how to accomplish it. And in our next episode, we'll dive right into the concrete process of doing machine learning in more detail, going through a step-by-step formula for how to approach machine learning problems.
Okay, let us continue our discussion. Why is that machine learning is crucial in artificial intelligence? So basically, machine learning is a subset of AI, no? That involves the development of algorithms that enable machine learnings again, no, to learn patterns and make decisions without explicit programming. So napag-aaralan lahat ng ni machine learning lahat ng mga bagay through patterns without explicit walang iba't ibang programming na ini-integrate, no? So machine learning is crucial in AI because it enables machines to learn from data, improving their performance over time. So natututo si machine learning gamit lamang yung mga data, no? Na nag-improve ng kanyang performance over time. Okay? It allows AI systems to adapt to new information pattern and changes in the environment. Without ML, AI systems would be limited in their ability to handle complex tasks and make accurate predictions.